Okay, Pre-Calc, this is 4.3. What we want to get done here is we want to solve problems involving the trig functions of real numbers and the properties of the sine and cosine of periodic functions. I'm not as concerned about this second part, okay? We'll get more into the graphs of sine and cosine in a few sections, but what I really want to focus on is angles in the coordinate plane. So the initial side is the beginning position of the ray, and where that is the x-axis, the positive x-axis. Okay. The terminal side is the final position of the ray after it is rotated about the vertex. The vertex is the origin. So for example, okay, these are angles in standard position. Okay, the initial side right here on your x-axis, positive, and your terminal side is here in quadrant 2. Notice, this is important, when you are graphing a positive angle, you are going counterclockwise. You're going this way. If you're graphing a negative angle, you are going clockwise. So you're going this way. So when we talk about coterminal angles are two angles that have the same initial side and the same terminal side, yet have different measures. Okay? Now, here is your original angle. Okay? That's 60 degrees, is the original angle. Okay? So here's your initial side, here's your terminal side. Okay? Now, to find coterminal angles, okay, they want you to find one positive and one negative. In other words, two angles that have the same initial side and terminal side, but they have different measures. So you kind of see down here where they have this negative 300. Negative 300 started at the initial side, and instead of going the positive direction, it goes the complete opposite. Now, how did they get negative 300? Well, what they did is they did 60 minus 360. That gives you negative 300. Okay. Now you see this 780 here. Okay. Now what they did for 780 is they started here and they just went around and around. Actually, that's probably not a good marker to use. Okay. They started here and they went around and they went around again and then they came here. So what they did is they took 60 and they added 720. Now, 360 is one time around all the way. 720 is two times all the way around. So what they did is they went around 720 degrees. Okay? And then they added 60 because they went 60 more. So that is 780 degrees. So that's where that 780 comes from. So basically you are either subtracting or adding multiples of 360 degrees or 2 pi, depending on what the angle is in, radians or degrees. Okay, so when they ask you to find and draw a positive angle and negative angle that are coterminal with the given angle. So part A, okay, now this is positive 30 degrees, so it's probably somewhere like right there. Okay, so that's 30 degrees. Now, a positive angle, okay, all I'd have to do is just add 360. So that would be 390 degrees. Now, when they ask you to draw that, okay, you're going to go around one whole time. Then you're going to go past 360, 30 degrees to right there. So that's 390. Now, the negative coterminal, you subtract 360. So you get negative 330. Now, from here, you start at your initial side, which is the positive x-axis, and go backwards all the way around, and then stop at the terminal side. So that is your negative 330. Here's your positive 390 right here. Okay? Now, part B, negative 150 degrees. I don't know why I have to write it. It's right there. Okay, so we are going to draw on the coordinate plane negative 150. Now, I start at the initial side and I go backwards. Now I'm going to stop just short of 180. Okay, if I go all the way up to the negative x-axis, that's 180. Okay, one time, and then the full circle is 360. So I'm going to stop just short. Now, the positive coterminal, I just add 360. So that's 210 degrees, which is really just me going from here all the way around. Okay. Now my negative, I take negative 150 and subtract 360. So that gives me negative 510. So I start here, I go around once, and then I keep going until I get to the terminal side. So the yellow angle is the 210, and then this angle is the negative 510. Okay. Now, when it's in radians, okay, when it's in radians, erase this, okay, okay, 2 pi over 3. Now, that is, now you could think of it two ways. You can convert that, so that's 360 over 3, which is 120. Okay, so that angle is right in here. Okay, all right. Now, it's in terms of pi, so instead of adding 360, we're going to add 2 pi because 360 equals 2 pi. So my positive coterminal, 2 pi over 3 plus 2 pi. My negative one is going to be 2 pi over 3 minus 2 pi. Okay, 2 pi over 3 plus 2 pi is 8 pi over 3. So I go here, I go around 1, and then I just keep going. Okay, now my negative angle, 2/3, 2 pi over 3 minus 2 pi. Okay, that is negative 4 pi over 3. So basically, I start, let's see, I can use pretty colors. My negative angle basically starts here. What am I doing? No. Goes here. Okay. So that's how you do the coterminal angles. Okay, it says, let theta be the acute angle in standard position whose terminal side contains the point 5, 3. Find the 6 trig functions of theta. Okay, so 1, 2, 3, 4, 5, 1, 2, 3. So there's my terminal side. Okay, so here's theta, right? Okay, there's my angle. Now, how am I going to find the 6 trig functions? Well, what you're going to do is from 5, 3, you're going to draw a line straight down and make a right triangle. So one leg is 5, the other leg is 3. Well, now I'm going to find the hypotenuse. So 5 squared plus 3 squared equals c squared. So that's 34 equals c squared. Whoops. So c is the square root of 34. So there's your hypotenuse. Okay. Now you can find all 6 of your trig functions. So sine theta, opposite over hypotenuse. So 3 over radical 34. Well, can't have a radical in the denominator, so you multiply top and bottom by that radical. So I get 3 radical 34 over 34. There's my sine. Now my cosine of theta, I'm going to run out of room. Cosine adjacent over hypotenuse, so 5 over radical 34. Now, it works out the same way that sine did, so we can just say it's going to be 5 radical 34 over 34. Tangent of theta. Tangent, opposite over adjacent, so that's 3/5. Okay, that's pretty easy. Sorry guys, I don't have a lot of room here. Cosecant of theta. Now remember, cosecant is the reciprocal of sine. So I would look right here. If I flip that fraction, that's radical 34 over 3. Secant of theta is the reciprocal of cosine. So again, I would look to this fraction right here. Square root of 34 over 5. Tangent theta. Tangent, again, what am I doing? Tangent, duh. Must be late in the day. Cotangent of theta is the tangent reciprocal. So flip 5/3 or flip 3/5 and you get 5 over 3. Okay? So basically what you're doing for these guys is you're setting up a right triangle in your coordinate plane, finding the missing side using Pythagorean theorem, and then use your trig functions. Okay? Now, the next example, all right, we paused, so that's why this part of the video is going to be kind of disjointed. We have the exact same problem here, okay? The only difference is now the point is in quadrant 2, okay? Now, when you do the Pythagorean theorem, everything comes out the same. I mean, if you do 3 squared plus negative 5 squared, okay, that's still going to give you 34, and C will still equal radical 34. So all these answers that we got are going to be the same, except some of them are now going to be negative, okay? So the sine is still, the sine is still, what was it over here? 3 radical 4 over 34? Same thing. Okay. The cosine was 5 radical 34 over 34. Now the only difference now, it's negative 5 radical 34 over 34, because the 5's negative now. Tangent was 3/5. Okay, now it's negative 3/5, because again, the 5's negative. Okay. Cosecant, still positive. Positive radical 4 over or positive radical 34 over 3. Secant, now negative radical 34 over 3. Okay? Or 5, excuse me. Whoops. Got ahead of myself there. Boop. Okay? Cotangent, now negative 5/3. Okay? So it's the same exact problem. The only difference is the 5's negative, so that affects your cosine and secant and tangent and cotangent. Okay. Okay. It says let theta be any angle in standard position. Let P be xy. So basically what they're doing here is they're just defining what x, y, and r are. So really r is the hypotenuse in this situation. Okay. So it's the same thing as we did in this problem and in this problem. The only difference is now they're like just defining it with an r as the hypotenuse. Okay. And here are the 6 trigonometric functions of theta. Okay. It's the same thing we did, guys, in the last 2 problems. It's nothing new. Okay. Now it says find the 6 trigonometric functions of 315. Now the first thing you have to do is figure out where 315 is. It's a positive angle, so we're going to go this way. Now 315 is not quite all the way around one time. Now here's the issue. All right. We don't know the sine, cosine, tangent of all those trig ratios of 315. All right, unless we use a calculator, but we're not going to use a calculator for this. Okay, we're not. So what we have to do is we want to put 315 in terms of 30, 45, 60. That's what we want because we know what those are. Okay, we should at least. So what I want to do is I want to find what we call, this is called a reference angle. Okay? All right. Reference angle is basically how much farther does the terminal side have to go to get to the x-axis in that quadrant. So in this case, the reference angle is 45 degrees. Okay? Because in 45 more degrees, our angle would get to 360. It would be one whole turn around. Okay? Now, we can do the 6 trig ratios of 45, and those ratios would be the same as the 6 trig ratios for 315. So the sine of 315, okay, now, real quick, we are in quadrant 4, correct? All right, we are in quadrant 4. What that means, cosine is positive, sine is negative. Okay? Basically, what we're going to come up with, guys, and this is sort of a shortcut, is the cosine sine basically correlates to xy. Okay? So whatever quadrant you're in, whatever sign the quote-unquote x coordinate would have, that would be the sign the cosine has. And whatever the coordinate of y would be, that would be the sign that sine would have. So the sine of 315 is the same as the negative sine 45, which is negative radical 2 over 2. Okay? Now if you go back to the special right triangles, you'll see where we got the negative radical 2 over 2. So now, cosine 315 is the same as positive cosine 45, because cosine's positive in the fourth quadrant. That is positive radical 2 over 2. The tangent of 315 is the same as negative tangent 45. Okay? So, what's the negative, well, first of all, what's tangent of 45? Tangent of 45 is 1, but since it's negative 1. Okay? So that means cosecant of 315 is just the sign flipped. Okay? So it's, oh, I got an email. That's what you heard. So this would be negative radical 2. The secant would be the same thing. Negative radical 2. Again, it's the reciprocal of the sine and cosine. And then obviously for cotangent, that's easy because the reciprocal of negative 1 is negative 1. Okay? Actually, we're going to stop right here. There are quite, actually, yeah, let's stop right here. The video is long enough as it is. It's 18.5 minutes. Make sure you get this done. Get this part of the video done. And then I'll finish the second part of the video for tomorrow. And we will do the rest then. That way we can kind of split things up a little bit.